7/4 is about multiplying and dividing radical expressions. Okay, it's simple enough. A product of square roots is square root of the product. A ratio of square roots is square root of the ratio. And we can simplify this a bit by multiplying numerator and denominator by root b. The point being is that this means the denominator just becomes b. It's called rationalizing the denominator. So root of a over b is root ab, all that divided by b. Oh, and by the way, when you write it this way, please make the divide sign longer than the square root sign, so there's no possibility of confusion. As I've said earlier, most of my students' errors are clerical. Okay, here we have a ratio of cube roots. We'll multiply above and below by cube root of b squared. Cube root of b times cube root of b squared will be just b. In the numerator, we get cube root of ab squared. Okay. So for example, root 3 root 15. That's root of 3 times 15. That's root 45. Largest square factor of 45 is 9. 9 times 5. Root 9 is 3. So this becomes 3 root 5. Here's root 2 sevenths. You can write it as root 2 over root 7. Multiply above and below by root 7. So as to rationalize the denominator, making it 7. And root times root 7 is root 14. So root 14, all that divided by 7. You have a cube root of 3 divided by the cube root of 2r. Well, I'll multiply above and below by the cube root of the square of 2r. So cube root of 2r times the cube root of the square of 2r comes out to 2r squared. 2r, excuse me. And this cube root of 3 times cube root of the square of 2r is cube root of 3 times 4r squared. And so you get cube root of 12r squared, all that divided by 2r. Here's 4 divided by root 6. To rationalize the denominator, we'll multiply numerator and denominator by root 6. That way, root 6 times root 6 is 6. So you get 4 root 6 over 6. Then you can cancel some common factor of 2 and get 2 root 6 divided by 3. There that is. Here's square root of 48x squared over square root of 8x squared y. I think it makes sense to first merge them into a single square root. Square root of the ratio, 48x squared over 8x squared y. Now, all right, 48 over 8 is a 6. The x squared cancels. We're left with a square root of 6 over y. Root 6 over root y. We'll multiply above and below by root y. So we rationalize the denominator to a y. And the numerator is root 6y. So you get root of 6y, all that divided by y. Now here you have the square of a sum of two roots. All right, now a square of a sum is square plus twice product plus square. So root 3y, that's squared, plus twice root 3, or x that is, plus twice root 3x, root 3, plus root 3 squared. Root 3x squared is just 3x. Root 3 squared is just 3. This is multiplies out to 2 root 9x. As you can pull out a factor of root 9. 3x plus 2 root 9 root x plus 3. Root 9 is 3. So 3x plus 2 times 3 root x plus 3. And in the end, 3x plus 6 root x plus 3. Now, you may recall that a sum times a difference is a difference of squares. If these are square roots in here, then these will cancel out to get an a minus b. So a sum of roots times the difference of roots is a difference. You can use this to rationalize denominators. For example, 1 over root 5 plus root 2. Root 5 and root 2 are annoying enough separately, and as a sum they're annoying, and dividing by it is even more annoying still. So we want to get rid of the square root signs in the denominator. So what we'll do is I'll multiply above and below the numerator and the denominator by root 5 minus root 2. Okay, When you have a sum of roots and a difference of roots, these are called conjugates. So we take this fraction and we rescale by the conjugate. We rescale by the conjugate of the denominator. Now, sum of roots times difference of roots is the difference, 5 minus 2. Above, it's just root 5 minus root 2. So in the end, you get root 5 minus root 2, all that divided by 3. There's that. Here we have a root 7 minus root 2 over root 7 plus root 2. Again, dividing by this isn't by this root 7 plus root 2 is annoying. So we'll rescale, multiply numerator and denominator by the conjugate of the denominator. Root 7 plus root 2 is root 7 minus root 2 below and above. Now, difference of roots, sum of roots times difference of roots is just the difference. 7 minus 2, that's what this says. And then we have a difference times a difference. And okay, it's square minus twice product plus square. That's standard stuff. So root 7 squared minus twice root 7 root 2 plus root 2 squared. Root 7 squared is 7. Root 2 squared is 2. Minus twice root 7 root 2 is minus twice root 14. 7 minus 2 is 5. Combine 7 minus 2 to get a 9. You get 9 minus 2 root 14, all that divided by 5. There you have a nasty one. 3 root 2 minus 5 root 3 over 2 root 3 minus 3 root 2. What a mess. So we'll take that fraction and we'll rescale, multiply above and below, by the conjugate of the denominator, a difference, a sum. All right, we have difference of roots, sum of roots. First is 3 times 2 root 3 root 2 times 2 root 3 comes out to 6 root 6. This outer comes out to 9 root 4. This inner is minus 10 root 9. This last is minus 15 root 6. Now hold on, 9 root 4 is 9 times 2. 10 root 9 is 10 times 3. As if 6 minus 16 root 6 here. And this times this, well, 2 root 3 squared is 4 times 3 is just 12. 3 root 2 squared is 9 times 2, which is 18. So, in the upshot, let's clean this up and you get minus 11 root 6 plus 18 minus 30 is minus 12. This is 2 minus 12 minus 18 is negative 6. Okay, and after some cancellation and division, you get 2 plus 11 root 6 divided by 6. Okay, some examples, and I hope I'm not repeating myself again. Root 3 root 15 is root of 3 times 15, which is 45, which is 9 times 5. Root 9 is 3, you get 3 root 5. 6ab cubed, root ab cubed, plus 8 root ab. Well, okay, 6 times 8 comes out here. Root of ab cubed ab here. So this is 48, square root of a to the second, b to the fourth. All right, square root means you take half the exponents. 48, a to the 2 halves, b to the 4 halves. It comes out to 48ab squared. I suppose this should be absolute value of a, but for all these, I'm assuming all the variables are at least positive, at least 0. Oh, we already did this one. Root 3x plus root 3 all squared is 3x plus 6 root x plus 3. We already did this one. 2 sevenths is root 14 over 7. Sorry, these were old notes, you see, and so I fear there's some redundancy. My apologies. Ah, special heart, you just joined us. Good. Where was I? So here, sometimes get lose track. Nope, sorry. 6, my apologies. Cube root of 3 over cube root of 2r. Well, right, it's cube root of 3 over 2r, but let's multiply above and below by the square of 2r, 4r squared. That way in the denominator we get 8r cubed, whose cube root is 2r, and 3 times 4r squared is 12r squared. So in the end you get the cube root of 12r squared, all that divided by 2r here. Yeah, root x minus root y over root x plus root y. We have the same fraction, and we'll multiply above and below by the conjugate of the denominator, which is root x minus root y. Okay, root x plus root y times root x minus root y is just the difference, x minus y. Here we have the square of a difference, which is square minus twice product plus square. Root x squared is x, root y squared is y. Root y times root x is root xy. So x minus 2 root xy plus y all over x minus y. Is this. Now here we have one sort of like the one before. 3 root 2 minus 5 root 3 over 2 root 3 minus 3 root 2. See that is. And then we're going to multiply above and below by the conjugate of the denominator. 2 root 3 plus 3 root 2. All right. If we go through all this times this, 3 root 2 times 2 root 3 is 6 root 6. Outer 3 root 2 times 3 root 2 is 9 times 2. Negative 5 root 3 times 2 root 3 is minus 10 times 3. Negative 5 root 3 times 3 root 2 is minus 15 root 6. And here we have difference times sum is the difference of squares. 2 root 3 squared is 4 times 3. 3 root 2 squared is 9 times 2. All right, and meanwhile above we have a 6 root 6. 9 times 2 is 18. 10 times 3 is 30. Minus 15 root 6. So, in the upshot, minus 12, minus 9 root 6 over negative 6. And after some 3's and negatives cancel, we're left with 2 plus 3 root 6 divided by 2. Uh, 125 A and B, 127 A and B. These are what the book calls lookalike problems. You have a 3 root A, square that. You have a 3 plus root A, square that. All right. Squaring this is easy. 3 squared is 9. Root A squared is A. 9A. You have a square of a sum, which is square plus twice product plus square. 3 squared is 9. Twice 3 times root A is 6 root A. Root A squared is A. Therefore this. Here we have the square of the square root of a difference. And here we have a square of a square root minus 6. So in here we minus 6 and square root and then square. Here we square root, then minus 6 and then square. This one's easy. A square root of a square cancels, leaving m minus 6. Here you have the square of a difference, which is square minus twice product plus square. Root m squared is m. 6 squared is 36. 2 times root m times 6 is 12, so minus 12 root m. So m minus 12 root m plus 36. Okay, that concludes that.